today what we're going to do is have a look at that practice exam very briefly. So the first bit, we're just going to go through each of the questions, say what sort you have to do for each one. We're going to give you guys a chance to have a go at doing that, and then if there's any ones you're particularly not sure of, we'll go through the answers for those ones. Yep. Oh, sorry, it's not up on the screen, my bad. So, do you guys have a paper copy of the... I got an extra copy here if someone needs it.
Okay.
Yep. 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 So that's actually something I want to talk about. Probably what I'm going to go through is just go through each question and say what type of question it is. And the reason why is if you have at least in the back of your mind, or this is like a sequences question, at least you know then I can go look at my formula sheet if I'm not sure about what to do. So we're just going to go through each question and say what we reckon it is. So this one, question 1, describe the association between the scatter plots. What kind of what topic did that come from? So correlations where you compare two sets of data. So this is our bivariate data problems. The same thing there. Question 2, the values of A and B in the linear equation. So it's asking you to find what.
Yeah, I didn't get that one. Wait, what?
So find the values of A and B in the linear equation y equals A plus bx, where r equals 0.6, x bar equals 1.165, standard deviation x equals 9.8, y bar equals 62.3, and standard deviation of y is 5.4. What type of problem is that? So I'd say sorry? Yeah, so it's once again that bivariate data stuff. So this is kind of like the stuff we were doing in our assignment, because we're talking about y mean, x mean, standard deviation. And we need to use our rules to figure out what A and B are, and that is on the formula sheet. So this is another bivariate data problem. Question 2, the equation which allows us to predict the resale price of a certain model of motorbike is based on its age. Resale price is 10 grand minus 1,250 times the age. Use the equation to predict the resale price of the motorbike, which is 5 years old. That would be the answer, but what type of problem is it? Kind of, it's the same principle as it, yeah. And then the actual resale price of a 5-year-old motorbike is that to determine the value of the residual. So that's to do with
It's still bivariate data.
yeah.
Up above, you're given an equation that has no context. Question 3 is a correlation equation.
There you go. That one's an interesting problem because you don't really need to have studied anything about it. You could do that without having any formulas around it. So that's kind of 2 free marks there, I would say. Okay, question 4, which is, we're starting to get into the bigger problems here, and it's probably worth, I would say, guys, when you flick through, see what the biggest weighted questions are, because that's where you want to spend a bit of time. Because if you can knock out this pretty well, you're going to get 3, 4, 4.5 marks. So it's worth twice as much time as some of those earlier ones. So construct a time series plot, well, it tells us right there, this is a time series problem. Time series. So we're just going to have to do a graph about that and then tell what's happening in it. So that's pretty easy again. So that one, I would definitely maybe, if I was doing this I'd put a star next to that. I want to do that straight away. I don't want to be rushed, so that way I remember all my stuff, like putting a title in, putting the axis labels in, because that's where a lot of those 4.5 marks are going to come from, doing the graph right. That's definitely worth the time. Okay, question 5. The time series plot below. Well, we're giving these away, aren't we? So this is time series. It's only worth 2 marks this time. Shows the average monthly price of oranges per kilo over the 2-year period. Describe the features. So that would be one of those ones where you're talking about like seasonality, structural change, all that stuff. Question 6, 2 marks again. fast food store has determined the following seasonal indexes. Seasonal indexes, what topic does that come under?
Yeah.
It no. It's the same as the ones we've been doing. So the last couple of questions. So we're still in the time series. So that's the example we talked about all the time with that is like selling ice cream over the year. Because depending on what season it is, depends on how much ice cream you're going to sell. So that's what your seasonal indexes are. Is a way of comparing different seasons. Okay? And that one was worth 2 marks again. I don't know, I don't have it in front of me. Determine the seasonal index for Sunday. All of those numbers have to add up to 7, because there's 7 values. So you just have to figure out what's left over from 7 for that one. But we'll go through them later. Question 7. Simple familiar, 2 marks. Determine an expression for Tn, the nth term of the geometric sequence. What type of question is that? Sequence. Easy as. Sequences. The new plan for telephone charges for international calls to Europe. A company suggests $5 for the first minute and then $1.20 for each minute. Summarized in the table below. Determine a charge for a call for 10 minutes. So once again, guys, this is one that you probably wouldn't need to use a formula to solve. You could get away with just doing it logically. But what type of problem is that? Is it there's 4 topics: bivariate data, time series, sequences, and Earth geometry. It's not Earth geometry. It's a sequence. Because can you see that this sequence is very similar to the one above, where just your initial value is $1.20, and then your common difference would be $5. So that's a sequence as well. Okay, and I think then there must be more to that problem, because it is worth 2 questions. There we go. So then you got to create an expression for part B. So you got to actually decide the rule for that one. Question 9. 4 marks, simple familiar. Time on the island in the Philippines is 8 hours ahead of GMT. Determine longitude. What would that be?
Geometric.
Starts with a G. It's not time series. Yeah, Earth geometry. Earth geometry. And then identify the time in longest term. Yeah, island, same thing, and then vice versa. Okay, question 10. 3 marks. Mount Isa has a latitude of 20.73 south, longitude of 139.49 east. Find the distance correct to the nearest kilometre of Mount Isa to the equator, the South Pole. What kind of question is this? Earth geometry again. Donald invests 50 grand into a bank account. This one's worth 2.5 marks, by the way. We're still in simple familiar territory, though. He'll be paid simple interest at the rate of 2.5% of the investment per annum. Find an expression for the value of the investment after N years. If he leaves the money in his account, after how many years will the total investment be worth 60 grand? What kind of problem is this? It is a simple interest problem. In terms of those 4 topics, what would be the easiest way to approach it? Using bivariate data, so that's all of your like standard deviations, correlation coefficients, all that stuff. Time series, which generally either involves a graph or seasonal indexes. Earth geometry, which is either about distance or time around the Earth, or would it be sequences? We have an initial value and it goes up or down from there. Sequences. Now, that is the worst cue I've ever drawn in my life. Okay, question 12. So 4 marks. Once again, this is probably one I'd be looking at. I should spend a little bit of time here. The growth of population of animals is modeled by a recursive formula. Pn equals 1.5 times Pn minus 1, where P1 is equal to 4. What kind of question is that? So you've got to find P2, 3, and 4. Then you've got to rearrange that to find a rule for it so that you're not just doing it recursively, which is a pain. And then just got to plot that, so that's pretty easy. Yeah, definitely be spending some time on that. Okay, we're seeing our first complex familiar problem here. So we should be expecting that there's going to be a little bit of messing around in question 13. The following table shows the price of oil in Australia, dollars a barrel over a 6-month period, and we're looking for the 3 mean smooth value. What type of problem is that? It's not a sequences problem. Sorry?
Seasonality.
It's in that same topic as like the seasonal indexes one. It's a time series problem. So the 3 mean value, the 5 mean value, the 2 mean value, none of them are particularly sort of horrible to calculate, but it's just remembering the different rules, because I'm pretty sure from memory those ones weren't on your formula sheet. Okay, so 4 marks, simple familiar, 4 marks, complex number. So this question now is worth 8 marks. So this is going to be a chunky question. The following table gives the average speed at which a car was driven around a test track and the resulting fuel consumption when it was driven at that speed. So 56 k's an hour, it had 8.1 litres per 100 kilometres, so on and so forth. Identify the response variable and the explanatory variable. Where do we compare response and explanatory? Yeah. And when did we learn about that? What topic in? We did learn about it last term. So are we talking about sequences, earth geometry, time series, or bivariate data? Bivariate. The trick between bivariate and time series is that they are pretty closely linked. Time series, one of your conditions has to be time. So that's why like seasonal index and stuff, because you're looking as time goes on. This one we're not looking as time goes on, we just have a bunch of random points. So this is sort of similar to our assignment, where you just have some linked data points that you then have to like talk about the relationship between. Okay, find the least squares regression line, identify the intercept of the slope, yada yada. Correlation coefficient is that, determine the coefficient of determination. Does anyone remember how do you find the coefficient of determination, by the way? Or just, you've been given the R value, how could you use that to find it? Yeah, just square it. The coefficient of determination is just R squared. And then you'd have to interpret that too. Okay, we're still in complex familiar, 4 marks this time. A group of year 12 students was asked whether they prefer to have their high school formal on a Friday night or a Saturday, and these are the results. We're talking about explanatory variables, response variables again, which means this is bivariate data. The reason I'm breaking it down like this is it's so that you know if you get stuck, what chapter to look at. So if you get stuck on this problem, you'd look at chapter 1 and 2, which is all the bivariate data stuff. We do have a breakdown of that in a little bit as well. Yeah, do that. Okay, 4 marks again. A piece of machinery in a factory is initially valued at $10,000. For every 1,000 uses, the piece of machinery is devalued by $100. That's a bit different. What topic would that fit under? Sequences. You're starting at a value and you're going up or down. And can you see sort of the value of this? So if you had tried to solve that using like bivariate data, like what you know, you would have ended up spending 10 minutes like trying to sub stuff into formulas and being like, what the hell? And it wouldn't have done you too well. But now that you know it's a sequence, you know, you're looking for an initial term, T1, you're figuring out if it's arithmetic or geometric, and once you've done that, you need to know if you're finding D or R. And once you've done that, everything else is pretty easy. It's just coming up with that rule that is difficult, and that's why it's really important to figure out what type of question you're being asked. Okay, question 17, 6 marks, complex, unfamiliar. So this is very nasty, this one. Sure is. Because it's got seasonal indexes in it, time series. Yep, so the trick here is it also says develop a least squared line to model the sales after deseasonalizing the data and use this to predict sales. So the least squares regression model, what topic did that come into? Yeah, so this is actually a link. That first, This question is linking bivariate data and time series. So there's two things you sort of have to have going on at once, which is what makes it tricky. And then question 18, we only got 2 to go. Factory has the intention of reducing its emissions of a pollutant gas. Initially, the gas is emitted at a rate of 2,000 kilograms a day. They're trying to half it. No, sorry, I misread that. The aim of the matrix is to reduce the amount of the pollutant by a fixed percentage Q each month. After 2 years, it is halved. Return. So you're trying to figure out what Q is. What kind of problem? Because you're starting at a value going up or down. And then last question, the difference between compound interest and simple interest is, after 7 years is $571. It wants you to find how much was initially invested. That's a really tricky one. Which of those 4 topics do you think would give you the best approach to solving that? Yeah. Because both simple interest and compound interest you can do using sequences. There is a fairly easy way to do it. So that's what all of the topics are. I will just show you as well. This is the breakdown of marks. So you can see that all the harder questions are sort of like from question 13 onwards, because they're the ones with complex familiar and complex unfamiliar. The other thing I'll just show you is... Did I not? Oh, I must have only put it on the other one. Sorry. Here. So I'll just show you guys. I've also put up... I should copy that over actually. I remember putting it up. I mustn't have put it in both. There we go. So each question, we've said what it relates to, and then some example questions that might be a little bit similar to it if you are stuck. So what we're going to get you guys to do for this session today is have a go at those questions. I know for me, the areas I'm strongest with are earth geometry and sequences and series. Sorry, just sequences for you guys. So those are my 2 ones. So if this was me doing the revision, I'd focus on the time series. I'm still a little bit, there's some stuff with seasonal indexes I need to go and like, oh, how does that work again? What rule do I use sort of thing? So those would be the ones I'd be practicing on, and as well bivariate data I'm not as strong on. So I would suggest the ones that you know, it's not what I'm great at, definitely focus on those. And we'll probably go, we might spend the last 20 minutes going through a couple of problems that if you guys have a particular one you want us to go through. But otherwise, I'll get you guys to have a crack.